Hello students, we are going to discuss quick solutions of All India AIATS Test Series JEE Mains 2018 and we will discuss Test 6 Code A Chemistry. Let's start our discussion with question number 31. In which of the following process magnetic nature of species does not change? First option is O2 positive to O2 2 positive. अगर हम O2 positive की बात करते हैं, it has one unpaired electron is present in O2 positive. So इसका nature क्या हुआ? Paramagnetic. Whereas for O2 2 positive, no unpaired electron is present. So O2 2 positive is an diamagnetic species. तो इसमें अगर देखें तो पैरामैग्नेटिक से डायमैग्नेटिक चेंज हो रहा है. So this cannot be our answer. Second is Cn negative to Cn. Cn negative has 0 unpaired electrons. 0 unpaired electron, that is, it is diamagnetic in nature. Whereas Cn has 1 unpaired electron. और ये क्या हो गया? पैरामैग्नेटिक. So यहाँ पे भी डायमैग्नेटिक से पैरामैग्नेटिक चेंज आ रहा है. So this is incorrect. Option 3, F2 to F2 positive. It has 0 unpaired electron. Or F2 positive, it has 1 unpaired electron. So it is paramagnetic. यहाँ पे भी magnetic nature change हो रहा है. So this cannot be the answer. And last option, option number 4, B2 to B2 positive. B2 has 2 unpaired electron. So it is paramagnetic in nature. Whereas B2 positive, it has 1 unpaired electron. So it is also paramagnetic. So in this process, magnetic nature does not change. So answer is option 4. Question number 32. A 2-liter vessel contains 4 gram of helium and 4 gram of H2 gas at 27 degrees Celsius. After some time, 50% of the gas having higher average speed is removed. What is the percentage reduction in total pressure if temperature remain constant? Initially, फोर ग्राम हीलियम प्रेजेंट है. 4 ग्राम हीलियम मतलब नंबर ऑफ मोल्स ऑफ हीलियम इज 1 एंड 4 ग्राम ऑफ हाइड्रोजन. तो हाइड्रोजन के कितने मोल प्रेजेंट है? 2 moles of hydrogen gas are present initially at 27 डिग्री सेल्सियस. अब उन्होंने कहा कि कुछ टाइम के बाद 50% of gas having higher average speed is removed. As we know, average speed is inversely proportional to under root of molecular mass of gas. So जिसका molecular mass कम होगा उसकी average speed ज़्यादा होगी. And between helium and hydrogen, hydrogen has lesser molecular weight, so it will have higher average speed. So 50% of hydrogen is removed. After some time, number of moles of helium would be 1, whereas number of moles of hydrogen, it will be 1, क्योंकि एक मोल हमने already remove कर दिया है. Now if we find initial pressure, Initially, the pressure is number of moles initially into RT by V, and finally pressure जो होगा, it will depend on final number of moles. Volume is constant. So if we calculate, the ratio of final pressure to initial pressure would be equals to the ratio of number of moles present in final mixture divided by number of moles in initial mixture. So this would be 2 divided by 3. And we need to calculate percentage reduction in total pressure. So percentage reduction in total pressure would be percentage reduction in total pressure. It is P initial minus P final divided by P initial into 100. So it would come out to be 1 by 3 into 100, that is 33.33%. So this is the percentage reduction in total pressure, and answer for question number 32 is option 2. Next question, question number 33. What is the correct shape and hybridization of central atom in XiO2F2? XiO2F2 it has seesaw shape. इसमें seesaw shape होगी, and the hybridization of Xc would be sp3d. So answer for this question is option 2. Next, question number 34. A graph between internal energy and volume is plotted at constant temperature for gases A and B. Correct statement regarding B and A will be respectively. अगर हम carefully graph को observe करते हैं, for gas A, on increasing volume, internal energy is constant, whereas for gas B, internal energy decreases on increasing volume. So हमें दोनों gases का nature बताना है. Before finding out the nature of gases, we know internal energy is function of volume and temperature. So change in internal energy would be del U by del T at constant volume into dt plus del U by del V at constant temperature into dV. For ideal gas, this factor is 0 because उनमें कोई भी force of attraction नहीं होता. So therefore, for ideal gas, as volume increases, internal energy remain constant. So A is ideal gas. अगर हम गैस B में देखते हैं, and if we talk about compression, जैसे वॉल्यूम कम हो रहा है, इंटरनल एनर्जी बढ़ रही है. मतलब the gases have dominant repulsion forces. So B is a real gas with repulsion forces dominant. So answer is option 2. Question number 35. A thermally insulated vessel is divided into two compartments by a partition of a insulated material. One compartment contains 0.8 mole of neon at 300 Kelvin and 1 atm. Other compartment contains 0.4 mole of helium gas at 600 Kelvin and 2 atm. When partition is removed, gases mix. Select the incorrect statement about the process. There is a vessel और उसमें एक partition है insulated material की. In first compartment, which contain neon, 0.8 moles are present at 300 Kelvin at 1 atm. And second compartment containing helium has 0.4 moles at 600 Kelvin and 2 atm. This is given. Now first option is final temperature of mixture is 400 Kelvin. जब हम पार्टीशन को रिमूव करेंगे, there will be a mixing of gases and नियॉन का टेम्परेचर बढ़ेगा जबकि हीलियम का टेम्परेचर कम होगा. And there will be a final temperature. Let us assume that final temperature is TF. And we know it is an insulated vessel, so heat gained by neon is equals to heat released by helium. So heat gain will be equals to NCV delta T, and number of moles of neon is 0.8 into 3 by 2 R. Final temperature minus initial temperature. This is equals to number of moles of helium into 3 by 2 R, 600 minus TF. So using this we can calculate final temperature, and final temperature would come out to be 400 Kelvin. So the given statement is correct. Next is final pressure of mixture is 3.33 atm. To find out final pressure, it would be equals to number of moles, total number of moles into R into final temperature divided by final volume. Final total number of moles जो होंगे, that would be 0.8 plus 0.4, that is 1.2. Final temperature अभी हमने calculate किया, it is 400 Kelvin. Now we need to calculate final volume. We can calculate final volume using initial data. So volume of first compartment that is occupied by neon is number of moles of neon into R into T divided by 1. This would be 240 R. और similarly हम second compartment का volume भी निकाल सकते हैं. It would be 120 R. So final volume would be 240 plus 120 R, that is 360 R. And substituting all these value, we will get final pressure would be 1.33 atm. और जबकि हमें कहा गया है the final pressure of mixture is 3.33 atm, this is incorrect. Third option, the entropy change for neon is 5.56 joule per Kelvin. Entropy change can be calculated using NCV ln T2 by T1 plus NR ln V2 by V1. And for neon, number of moles is 0.8, CV is 3 by 2R, and final temperature is 400 divided by 300 plus R Allen. Final volume is 360 R और initial volume था 240 R, so it will be 3/2. और अगर हम इन्हें solve करेंगे so we will get the change in entropy for neon is 5.56 joule per Kelvin. So the given statement is correct. Last option, option number 4, the entropy change of neon is more than entropy change of helium. जैसे अभी हमने डेल्टा एस नियॉन का निकाला, सिमिलरली वी कैन कैलकुलेट डेल्टा एस फॉर हीलियम. नंबर ऑफ मोल्स ऑफ हीलियम आर 0.4, 3/2 R, Allen 400/600 plus R Allen 3/1. So it would come out to be 1.63 joule per Kelvin. And we can clearly see कि नियॉन की एंट्रोपी चेंज ज्यादा है हीलियम से, so the given statement is correct. और हमें निकालना था इनकरेक्ट स्टेटमेंट, so answer is option 2.